Okay, let me give you the example. Representations of functions as power series. Okay, let's express 1 over 1 plus x squared as the sum of a power series, and find interval of convergence. Okay, now, like I told you before, that uh, the whole point is depends on this 1 over 1 minus x. Okay. Now look at the questions, the functions. Let's write down the functions 1 plus x squared. Now the first thing you need to do to represent the functions as the series is you need to manipulate the form, so the form will be, it looks similar to the 1 over 1 minus x. So 1 divided by 1 minus x squared. Okay. So look at the left. Okay, is 1 over 1 minus x. What you need to do is you need to replicate the form. So 1 over 1 minus x squared. Okay. If this is x to the n, right? So it's like if you have x here, then this will be x to the n. So what is happening if we have negative x squared? So we just change this x with negative x squared. Okay, got it? So this will be sum of negative x squared and with the power of n. Okay, or you can make more smooth the form. You can separate the negative one if you want, like that, and x to the, and you can actually showing what it's look like if you expand the series. So this will be 1. Okay. And converge, because it's also geometric series, the converge will be when ratio is less than 1. And this is, we can write this, but it's squared, so we can also write this. It can be positive, negative, so here. And as a conclusion for the interval of convergence, it will be from negative 1 until 1. And of course, we can also, if you want to calculate the radius, you can also apply the ratio test, but because it's not asking the radius, it's not really necessary to calculate. Okay. Okay, that's the first case. Okay, let's try the second case, another example. It's the same questions, but the functions is 1 over x plus 2. Now you can try this 1 over x plus 2. And always remember the idea. You need to replace 1 over 1 minus x and replace with it. So First thing, you need to manipulate this part to become similar with uh, this functions. So it's like a playing a game, right? We just try to solve and find the form, the pattern. Okay. Maybe first is maybe switching to its left and x here, right? 2 plus x. And then either you can factorize 2 outside, or you can change this positive to negative negative. That's also fine. Either way, it's okay. But at the end, it will resulting the same result. Okay, so you can try from 2 plus x, okay, and then, or maybe I will write to the left from the left. You can factorize 2, and then from here, you can write like this. So it will be half, and then we can write the sum. Okay. Or if you want to make it, you can also rewrite the form and include the half inside the sum. So it will be -1. And then the series will be converges. So converge when the ratio is less than 1. So this is actually this. So the interval of convergence is from -2 until 2. Okay. Another example, if you have, let's say, function g, now you have x cubed divided by x plus 2. This part is the easiest part, actually. Do you know why? Because we already done the x plus 2 before, previously. So if you see any form that you know you already find the sum for the bottom part, what you need to do is just multiply x cubed to the sum. So this will be resulting the sum. Let me just write the the previous part. And because it's x and plus 3, because it's multiply x cubed. And that's it. And actually, how you write the sum, we start from 0, right? We can also shift the n to the, let's say for this case, we can shift to the maybe n equal 3. And we just shifted the all the n. Because it's 3, so I need to make sure that this is, the first is positive, right? Yeah. So this is just n, and this part will be plus 1 minus 3, so minus 2. So this is 3. So n is plus 3. We shifted negative 3 because we move it to the right, the order. And this will be negative 3 also. But this is not negative 3, but this is just positive or negative. If you need to be, unity 3 should be positive, then this should be positive, right? Because 3, it's become positive, right? If you start from 0, it's 1. It's 1, right? Okay. Okay, any questions? No? Okay. So most of the cases, what we will be doing is we just need to manipulate the form, find the sum, and then find the interval of convergence. Okay. Okay, let me move on to some theorem. But before the theorem, let me give you some idea. Okay. If the functions is expressed as the sum of our series. Now this is the tricky part. Okay. Now we have 1 over 1 minus x, but it has squared here. Or maybe let me write this as, let's say h. Okay, let's say h. What we have done, or what we are doing previously, is we are equaling or manipulating the form based on this, right? Let me just write this expansions. It's 1 plus x squared plus x cubed plus until n, and then this is the sum. And then let me write the this part. Okay. Now let's focus on this g. Okay. We have 1 over 1 minus x. We don't have this all plus 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 and the sum. Okay. Now think how you can get this form from the first one. Hmm? Hmm? Squared? Squared? Okay, you can also square. And any other idea aside from squaring the 1 minus x? Yes? Who? Divide by 1 minus x. Sure, but does it help this part? All right. What you can do? Square? Square root? How to square root of this? Yeah, you can square this, right? But how you can square this? That's also trouble, right? Okay, let me write here. Let me write. What if this? Can you derive? Of course, the bottom part. If you use the question rule, the bottom part will be 1 minus x squared, right? This is 1, right? 1, right? Okay. So this is another idea to solve. Okay. So we can think the functions as a derivative or even integration. So we can derive this. And by doing so, we just derive this. This become 1 plus 2x plus 3x squared plus 4x cubed and so on. Okay. This is 1, 2x plus 3x squared plus 4x cubed and so on and so forth. This will be, now it's shifted to 1, right? And this is n, x, and minus 1. And this is can be the case for the functions. Okay. So whenever you see any the functions, aside from manipulating the form and make it 1 over 1 minus x, if you see if it is related to some derivatives or some integrations, you can derive or integrate all this part. Okay. Now let me give you the term, the official definitions, and what is really happening here. Okay. So if the power series this is the general form. This has radius of convergence. R is greater than 0. Then the function defined by its equal sum of the Cn x minus a and in the power of n. So the definition will be the functions is differentiable, and because of that, it's continue on interval, the interval of convergences from, oh, wait. Uh, okay. From A minus R until A plus R. So if you have F prime, it will be C1 plus 2C2 and then plus 3C3 x minus a squared, and plus and equal the shifted sum of n, Cn, x minus a, n minus 1. Okay, that's for the derivative. Or you can also have the integration of the function itself, in which, because it's integrate, you will have another big constant, because all integration should be plus c, right, at the result. So you need to plus c and then plus the initial part, integrate all, plus c1 plus c2. This should be c plus the sum. You can also write the term as ddx of the sum or integrations. Okay, so that's the theorem. So you can actually relate the functions to the derivative or integrations. Okay. Let me give you some examples and maybe some exercise. And if you see the form, the power series uh, has form like 1 plus x plus something, or if you relate to its derivative or integration, it still have the same form, plus 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 plus, right? So one of the functions or one of the purpose for the power series is to approximate, doing approximations, because you can set up any functions, and maybe you need, or you can manipulate and try to find the series, and from the series you can actually find the approximation. So you don't really need to be able to integrate or derive exactly which with certain method. But if you can define the series as define the function as the series, then you can approximate some value, right? So that's one of the purpose. And you need that maybe in the future when you deal with some database, some data set, or any simulation part that need to be done by approximating the value. Then you can actually try some formula, okay, which, but usually because you will learn some software. Actually, what the software done is the iteration part, the computations part is they are approximate with certain formula from what we have learned in calculus. Okay. Okay. So it seems like pretty messy, right? But if you can see the pattern, you don't really need to like, do I need to memorize all of this? No. See the pattern, okay? So the first thing you need to understand is what is the power series, okay? So if you look at the general terms, the general terms is from CO, C1, and then x minus a, and we have deal with this x minus a last week or maybe last Monday. So x minus a, we deal with the some certain value nearby the a that might have convergences, right? If when we deal with the radius of convergence and find the interval, okay? So we have x minus a and x minus a squared and plus a cube, 4, 5, and n, right? And this part you can derive. So C1 x minus a just become C1. C0 becomes 0 because it's constant. C2 is 2. It's become its derivative, right? And if you see the integration part, C0 becomes C0 x minus a, and you do to plus C because it's integrations. And C1 become x minus a, and it need to be integrated. It become squared and 2. So I need to plus 1 also, okay? So it's not really uh, it seems complicated, but it's not. Okay. The tricky part or the difficult part is when you are dealing with this, some exercise. Well, let me give you the exercise. Okay. Try this. So find power series representation. And also same question, but different functions. Or let me write G. Let's start with some obvious functions that you know the derivative of. If you don't know the derivative of integrations, you need to check calculus 1. Okay. The first is ln. The second one is tangent inverse. So ln, you prefer to integrate or derive? Derive, right? Yeah, you will get 1 over this part, right? And multiply with the chain rule. The chain rule is just x, just 1. Yeah. Let me move here. Or let me move here. Okay, let's start to see the form. If you derive this, it will be 1 over 1 plus x, okay? Which is similar to 1 over 1 minus x, right? And this is the key, okay? So first, we try to manipulate the form from here, and we get 1, and then minus x plus x squared minus x cubed, and so on, right? Now, to get the ln 1 plus x, this is actually integrations of this, right? Which means we need to integrate all of this, okay? So when we integrate that, we got x, and then x squared over 2, and then plus x cubed over 3 minus x fourth, and then plus dot dot. And then at the very end, don't forget to add c for the results of the integrations. Now this is sum. And then because we still have this c here, the big C, we can check some x, okay? We can check some x. So putting x, put x equals 0. Ln 1 plus 0 is equal c plus plus x minus x squared plus over 2 plus dot, 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 right? And all this part will be 0. And also because of ln 1 is 0, so c is also 0. So the conclusion is ln 1 plus x is equal sum of and don't forget that x should be less than 1. Okay. So now, aside from manipulating this form, this red form, you need also to think the derivative form or the integration form. Okay. If you are missing out the calculus 1, all of this part, you will not be handling it very well. Okay, I assure you. If you are not really focused on calculus 1, all of this part will be impossible. Okay. So let's see this part. Okay. The tangent inverse. Yeah, tangent inverse 1 over 1 plus x squared. Okay. So 1 over 1 plus x squared. Or let me write tangent inverse x as this, right? Okay. Uh, Anyone agree? Okay. Please don't forget the calculus 1. Okay. So tangent inverse is 1 over 1 plus x squared. And remember that we already done this 1 plus x squared, right? So what we need to do is we change this form and then we apply to 1 minus x squared plus x4 and dx. And then let's find the integrations. So x and then to find c, okay, we can put x equals 0. So tangent inverse 0 will be c plus 0, right? So c is 0. So tangent inverse x will be x minus x cubed plus x5 minus dot dot dot. Okay, and this will be equal the sum of it's become the odd number to n plus 1, right? 1, 3, 5, 7. And again, this alternates part, it depends on which term that you want to observe. For example, if you start from this x is positive, right? And it starts from 0, so it become 1, right? It become 1 here. So this part is actually you can try some n and try some well, positive or negative. Okay? If it is negative at the very beginning, then you can maybe change this n into another part. Okay? But it's up to you. Sometimes you will it will have several several series, but actually that series is the same, but different form. That's still okay. There is not exact like one answers only. Like it may be several answers, but it will be having the same series. Okay. Okay. Let me give you another uh, exercise. Okay, let me give you the exercise. The question still same. Find power representation. Uh, of the set of the functions. Find power series representations. Okay, 3 questions. Let me just give you some minutes to solve these 3 exercises. What is this? 8 from which one? Oh, this one. Hmm? How you integrate this? You integrate or derive? Can you derive that? Can you derive this? Can you write the questions clearly? 1 plus 4x, right? 1 plus 4x and then squared. Is it the same as, let me write here, this, right? Can you factorize 4? Yeah, this is wrong. You have a long way to go, man. Really, really long. This was supposed to be the really basic. Why? Before you derive, before you integrate, you need to know why you need to do that. If you are going without directions, then you will be getting nowhere. right? So you need to know why you need to derive and integrate. First, you need to find the clue from the original function first. What you need to do from here, okay? Okay. Do you get it? Not really, right? Okay. Yung nanggating nga. You skip some part, this part. In the next chapters and sections, you will be lost. Okay. Wait. I think this is a good approach here. But before you going to the square here, you can try for another functions that you create 1 over 1 plus 4x. That's first. You try to find, and then you need to find how to relate 1 over 1 plus 4x to this square. And then later you need to multiply with this x and how to make it happen.
But this one,
Mhm.
just added.
Yeah.
Why cannot I just add in 1x?
Yeah, but this part, I think this part is, the problem is this part, the square part. So you need to try without square first. And then later, how to make the square, right? Maybe it's their derivative, right? Right? Yeah. You have the PDF? Yeah, that's good. Yeah, you can check the example. In every example, especially this part, you can check the example. And for some cases, you need to look back to chapter maybe 6, maybe 7 for integration or derivative part. Okay. You have a problem? Yeah, here, right? So this part, you cannot really going through from here only. So you need to maybe first think about some functions. Maybe let me give you a clue. Maybe you need to think this function first. And from here, can you think any functions that make this square? Maybe if you derive this, this will be right, and then this will be minus 4, right? And to become like this, what you need to do? You need to multiply with this, right? You get it?
Yes.
Yeah. So the first thing, you need to find the series from here, and you have the expansion like this one, and then you derive this, and later you get this sum, right?
Yes.
And this sum you need to multiply with this. Get it?
So I got this function is
Yeah. From derivative. Yes. And just multiply with the x, yeah. And then
I didn't know it. I just
oh yeah. Get the s, the area is correct. Gimana? Bisa nggak?
ini pas sama yang kalian
Pas zaman kamu kayak gini nggak sih?
enggak
Iya ya.
enggak ada kayaknya Pak.
Masa sih? Ada kayaknya selewat kayaknya ya.
Oh ya kayaknya apa dilewatin terus.
Ini nih McFlower ini. Ini kan sebenarnya pendahuluan McFlower ini.
Oh.
Nih. Nih kan? Nih. Ini sebelum McFlower ini. Nih.
Oke, jam aku dulu di sini ya, Pak.
Ini.
Oh ya.
Nih. Representation. Buat saya tuh kayaknya nggak banyak latihan.
Iya dulu kayaknya lebih.
Ini. Okay. Iya, iya.
Aku kan nyobain aku integralin kan.
Ya.
Aku malah jadi hancur gitu. Kayak,
Iya, berarti hancur, jangan.
berarti jangan pakai integral kan.
Okay. Uh, okay. Now let's see the number one. Okay. Let's see from here only. We have x and then over 1 plus 4x and then squared, right? Now, first, before you're going to do something crazy here, just think about this bottom part here. It has squared, right? I think I have mentioned in the previous slides sections before that when you have squared, probably it was because of the you derive something and it will be having squared, right? So first, maybe you try, okay, you try to find some functions. Okay? Maybe you make randomly or any functions that you can think of. Let's say h, functions h. Let's say this is the functions, okay? Let's say this is our functions, okay, aside from the question. Okay? And then think how to make this 1 plus 4x becomes this square, like we did before. One way is to differentiate or derive this, right? So what you need to do first is to find its derivative. Okay? Derivative, you can think of the quotient rule to make it squared, right, at the bottom. So at least you get the squared part. But here, because of the quotient rule, it will be minus 4, right? At here. But at least we get what we want. We want this to be squared, right? Now, what we can do from here, uh, actually, there are several actions that you can do. You can choose. Okay. First, you can choose to take this part, the h, take the extensions, what it is, find the sum. And after you find the sum, like this extensions, all this part, derive that part. And you can have the sum with the result from derivative. Okay. And then this negative 4, you need to make it just x, right? So what you need to do is just multiply with this to make our original function. Okay, got it? Now let's do the first step. So let's do this. 1 minus 4x. And this will be the sum of negative 4, negative 4x. Yeah, let's just write here. And then let's derive, okay? Let's derive, and this will be, it will be shifted to 1. And then this negative 4 with power of n. And it will be n, and then x, n minus 1. And we need to multiply with negative x over 4. So let me simplify all of this. -4, and +1, and +1. Or let me just give you the shifted version, and x, and they need to be calculated with the so negative. Let's separate the alternate series, and then for with n, and then n+1, and then x, n+1. Okay. You need to be careful for all the calculations for the power. Okay. Yeah, the negative. Okay, I think it's correct. Okay, now the second one. I think the third one I can give you for homework. So let's try this, the second one here. Now, remember that we have done the 1 and then 2. We have done the plus, right? Now it's minus. So let's say we have this function. So this is 1. Or we can write this as half of the series of x over 2 with the power of n. Or we can write down this as xn and then 2n plus 1. This is for x less than 1. So x is less than 2. Now we have, let's say we have 1x minus 2 squared. Okay. And again, because it's also the same or similar problem, we have the squared. If we want to make this happen from here, we need to just think the first derivative, right? So the first derivative, let me just write this as uh, d dx of 1 over 2 minus x. I think this will be correct, right? The negative will be switched. So you need to derive the sum. So it will be n, and then x n minus 1. And maybe we can shift to 0 back one more time. And this will be n plus 1, 2n plus 2, and then x n. And the question is f is x cubed, right? So the last thing we need to do is we need to multiply the x cubed with our sum. We can just add plus 3 at the very end. The result, like this one, is from n equals 0. But depends on the questions. Maybe the form they want to be start from 3 or maybe 2. It depends on the question. So you need to be also careful there. Maybe you find here and then maybe you see the options. Oh, there's no one that really is the same. But when you change, maybe it will have the options. Okay. I think I will finish up until here. Okay. I will finish up until here. Please do some exercise on. I know long holiday await for you, right? uh, but I must inform you that we will have the midterm, but it will be around third week. Uh, let's see the schedule. Uh, maybe 21 or 26. Maybe 26. Okay, maybe 26. The last week of April, 26. So the midterm will be from chapter 10 and chapter 11. Okay. So if we finish chapter 11, if we finish this, maybe next week we finish and then we move to chapter 12. Chapter 12 will be not included in the midterm. So just midterm is only 10 and 11. Okay. I think that's it for today.